Hi, Chris McLeod here with Fire Apparatus and Emergency Equipment. Welcome to this episode of TIC Talk. Today we're going to be talking about technical rescue. Again, my guest is Brad Harvey. He's the Global Product Manager for Thermal Imaging at Bullard. And also he brings 30 years of experience in public safety. He's been a firefighter paramedic. He's been a police officer. He has experience on tactical teams. So there's a lot of institutional knowledge for the fire service, in our case, that he brings to the equation, as well as his experience at Bullard. So, Brad, again, welcome back to TIC Talk. As I said, we're going to talk about technical rescue today. Our last episode, we talked about USAR situations, and we touched on technical rescue operations just a little bit. We didn't get too far into it. We talked a little bit about water rescue, which we'll talk about here today. And we're also going to get a little bit into some hazmat stuff today. So, so kind of a packed episode here. But I guess to just get us started, when we talk about technical rescue, and there are all different types of disciplines, and we also talked last time about how a thermal imager has actually made our firefighting far more efficient, our fireground operations far more efficient. What are some of the applications for technical rescue that a thermal imager can be used, and how does it increase the efficiency, our efficiency as rescuers in those types of situations?
Sure. It's an interesting topic because, as you said, most people, when they're thinking about thermal imagers, are thinking about structural firefighting. And that's probably appropriate, right? But if you've invested in the technology, where else can it play a role? And I'm also a big advocate for not forcing thermal imaging into a scenario just because you own it. There should be a value return for that. So when we look through the list of all the tech rescue specialties, like you said, we talked wilderness search last time. We talked about hazmat and water. But, structural collapse can play a role. There usually, if there's, a big dust cloud or whatever, thermal imaging is really good at seeing through those things, or people that might be obscured by dust and light debris. Anything where visibility is going to be limited. So if you're doing a confined space in the sewers, as an example, the thermal imager is going to see further down a sewer pipe than a flashlight or anything else. And that's typically a cool environment where victims stand out really well. Subterranean, same way. So cave rescue, mine and tunnel rescue. Probably, which I think we'll talk about here a little later, probably the biggest value is in water rescue. But you could extend this even into rope rescue. If you're doing a complicated system of, maybe you've got a 5-to-1 or a 7-to-1 mechanical advantage, or one advantage going to another advantage, and the system is binding, or you've got somebody going over an edge where the rope is moving, the thermal imager can show points of friction because friction generates heat. So if you're wondering where your system might be binding up, a thermal imager might be able to show that to you. It also might not, right? But these are things that you could work with in training to see if it's helpful.
We do that a lot. We kind of sometimes get focused on one area. So we're thinking about victim location or locating victims. We forget a lot of times about how it can help us with the equipment that we are using to locate and extricate or remove victims. So a great point there. Now, we often, as great as thermal imagers are and as much help as they are, they do sometimes have limitations. Again, we're going to talk a little bit about the water rescue in a minute, but thinking about other technical rescue situations where maybe it's a confined space, maybe it's a collapse rescue, maybe it's a trench rescue. Are there any limitations? And I say limitations, but that's actually not the best way of describing it, because most of the time we can get around anything through training.
Yeah.
So is there anything that firefighters or rescuers need to be thinking about when they're going into service with a thermal imaging camera during a technical rescue situation, where, and I think really a lot of times it has to do with how you're reading the information that is coming across onto the screen of the camera. What do we need to be thinking about as we're going into those situations, given how a thermal imager works?
Yep. Great question. So the first thing, and you just can't drill this into people's heads enough, a thermal imager can't see through anything. The first surface it comes into contact with is the limit of its ability to see. This gets a little confusing because if you're looking at particularly like an exterior wall on a building and you're looking from inside, you can see the shadows of the studs in the wall. And it gives you the perception that you're seeing through the wall. But you're not. Those studs are just creating a thermal difference on the surface of the wall that you're seeing. So, this is important to understand that, like, as soon as something is underwater, it's invisible. It could be just, a centimeter underwater. It's invisible. If if somebody is, under debris, they're likely invisible. So there's a limitation in the surface position. But the second thing that we're thinking through in the tech rescue perspective becomes interesting, because we tend to think structural fire when we think thermal imaging. We get very focused on temperatures, specifically what this temperature is and what, when we're thinking about non-fire situations, it's more about the evaluative capability of the technology. So we talk in terms of being a quantitative or a qualitative view. A quantitative view means it's measured and numbered. So it's a quantity of temperature. So we can tell you, 146 Fahrenheit. But quantitative does a single point measurement. Qualitative is what we're actually viewing. So qualitative is taking everything into consideration and showing me the differences. So when we go back to that rope rescue system, being able to find the point of bindage, it doesn't really matter what the temperature is. It matters that that part of the rope is warmer than the other parts of the rope. So, understanding this difference can play a big role in understanding what you're seeing and interpreting what you're seeing. If you're in a con space situation, as an example, where there is machinery or motors or electrical lines, a live line typically will have temperature to it. And so where you might otherwise be oblivious to the fact that the line is there, if you're looking in an area that all appears to be one temperature and you've got this pretty straight, gray line running through, it's something to reveal information you didn't otherwise know. And then I think last to your point, the main limitation is the experience of the operator. So if they understand like the technical limitations, it can't see through a surface, and what we're looking at is anomaly detection. We're looking for, it's like Sesame Street, right? One of these things just isn't like the other. That's really what qualitative imaging is. You understand those two things, then the only limitation is the experience of the user.
Brad, I think you might have dated yourself a little bit there.
Probably.
With which one of these things is different than the other. I don't know if they're still. I know Sesame Street's still around, but I don't know if that particular part is.
It may not be, but you laughed, so you're in the boat with me, apparently.
Oh, I know. Oh, I'm with you 100%. So I wanted to talking a little bit about more about water rescue. When we talked about it last time with USAR, I think we talked a little bit more about where it can't be used in water rescue, but I think that there are a number of ways that that can be used. I don't want anyone to think that in a water rescue situation, a thermal imager is not going to be of service during that. And again, I do think it comes back a little bit. You were mentioning the experience of the user. It really, so much of thermal imaging has to do with proper interpretation of what you're seeing on the screen. So walk me through, with water rescue applications and scenarios, where the thermal imager is going to be a help.
Yeah, I'm glad you brought that up, because you're right. Although I just got done saying that as soon as it's underwater, we can't see it. The flip side of that is actually the beauty of it. And water rescue may be the defining use for thermal imaging in technical rescue, because the thermal imager can't see through the surface of the water. What it sees is a reflection off the surface. So it's almost always seeing the sky. The sky has no real surface to it. So water almost always appears universally cold to the thermal imager. That makes a human being stand out as unusually hot compared to that type of a background. So you get a really stark contrast of the person to the water. And this is day or night, it doesn't matter. But what that can help with is, depending on the type of water you're in, but here in Kentucky, a lot of the moving water can be brown and murky. So you have a brown-haired victim in a large body of water. That can be hard to see even with your eyes in broad daylight. You look at the same body with a thermal imager, you'll typically see this big sea of black and then this white spot, which is your victim. So it can help in where you have an unknown victim location. It can help survey wide areas very, very quickly. But you flip that around to more dynamic situations. So swift water, if you're monitoring for a victim in the water, particularly during floods or weather events, it can be hard to spot a brown-haired person floating down the water amongst logs and debris and all this other stuff. A thermal imager simplifies that as just a surveillance tool. If you have rescuers in the water, so you could use the thermal imager as a surveillance tool for accountability purposes. But if they're in an inflatable and it were to overturn and you've got 3 or 4 guys in the water now, thermal imager makes it easier to follow them. And this is all really because of the characteristics of water. Water gives us that cold-looking background, which then makes warm objects very, very easy to spot. And so I think water is probably one of the greatest opportunities for it to make a significant difference.
We mentioned in the beginning, and you've mentioned the term a couple of times during this, hazmat. And while we might not often think of hazmat in technical rescue situations, there are a lot of times where, in a confined, we talk about confined spaces, but a confined space could be the office you're sitting in right now.
Mm-hmm.
And if there is a 50-gallon drum in that office that for whatever reason is off-gassing something, and then you've now gone down, there are uses for thermal imagers in a hazmat type of situation. I brought up the 50-gallon drum. We can see the level of that drum off, or the level, depending on the liquid,
Mm-hmm.
but we can see the level of whatever is in that drum at times. So so there are a number of different ways that we can use a thermal imager in a technical rescue situation that does involve some hazmat as well. So I think it really does bear mentioning, how we use thermal imagers in a hazmat situation. I'm sure you have more examples, certainly, than just a drum with the level and everything. But talk to me about a bit about thermal imaging in hazardous materials responses. Particularly thinking about where we would use it in a technical rescue situation.
Sure. So, and to be clear, I am not now, nor have I ever been a hazmat technician. I mean, I was awareness and ops, but
Mm-hmm.
and I don't totally understand hazmat technicians, by the way, but that's beside the point. So, but from a thermal standpoint, I think you could kind of break these into two different categories. You could think of them as true hazmat situations. So like you said, we're called because of a recognized hazardous materials event, or hazmat that occurs within another event. So an auto accident, as an example. If you have fluids down, there are multiple different fluids there. That's technically a hazmat. If you've involved a UPS truck and a UPS truck is leaking, who knows what was in the boxes in the UPS truck. So although you're handling an auto accident, you kind of have a hazmat, or at least a minor hazmat, buried in. When you think about the full hazmat situations, I think the most common thing that people use it for is exactly what you said. It is seeing a product level line. And this is typically pretty easy to do. There's kind of three situations where that becomes not definitive. The first one would be if that vessel is completely full. So if it's full to the top, there's no line to see. If it's completely empty, the same situation. If it were to be thermally insulated, then that's also really hard, because the whole idea is to keep temperature from getting out where we could see it. So those three things would interfere. But otherwise, it's pretty easy to see a product level line on a wide variety of containers. And the best example would be like your backyard grill. I use it all the time to go out and look at how much propane that we have left. And interestingly, you could do a little chemistry training within this. If that propane cylinder has been unused for a day or so, it can be hard to see the product level line, but you usually can. It's when you open it and you start to flow propane, it becomes really easy, because propane under pressure undisturbed is typically in a gaseous state. But when flowing, it'll separate into a liquid and a gas. And that makes it really easy to see from outside of the cylinder. So you've got product level lines. The other one, and I did bring a picture, if you could throw it up on screen real quick, but this is just another thing to think about. So to be clear, this is not a hazmat situation. This is just a leaking hose line. This was sent to us actually just a few weeks ago. But what you see is two distinct puddles here. Looking with your eye, what you would see is wet concrete. But when you look at the thermal imager, you do see two distinct puddles. These are coming from the same coupling leak. So this is just a hose coupling. The puddle on the right is leaking from the coupling directly onto the ground. The puddle on the left is water spraying from that coupling over onto the ground. And simply because they took two different paths to get there, they appear to be two distinct puddles, two distinct temperatures. But we know the water is the same temperature and the ground is all the same temperature. They just kind of, this is kind of that qualitative difference. I don't need to know the temperature of each one, but what I do know now is, with my naked eye, I would see one puddle. What I know now is I have two puddles. So if I suspected like that UPS truck is leaking, I could look at it and potentially see if what I saw. So that dark line there in the center, this is my term, I have no idea if it's correct, but I would call that the interface of the two. If you had a bright white line there with some, fading of, maybe you're having an exothermic reaction between these two things. If it was, really, really cold there, maybe you're having an endotherm, you could see interaction, but I think what it does is it takes what otherwise would look as a single puddle and it gives you a different perspective on it, that now I understand it to be two puddles. What that changes in your response, I don't really know, right? But it is information that you otherwise wouldn't have had simply because you took the opportunity to look. The same thing happens, one more thing I guess to mention, is if the chemical has a specific gravity of less than 1, and it's not a polar solvent, then it floats. And so if you have fluids, you have a car accident on a bridge, maybe it's a small creek or something, and you're just wondering, how far down do I put the floaties? Try with a thermal imager and look at the creek, because a lot of times a lot of the hydraulic and petrol type chemicals, they float. And so you can see kind of how far down the waterway that goes. If the whole waterway is gasoline, it doesn't work again because you don't have any difference. But that's typically not the case.
So thermal imagers come in all kinds of different shapes, all kinds of different sizes. Are there, for tech rescue situations, are there any types that are more, I guess, conducive to use in those types of scenarios?
So I think any thermal imager is better than none, right? So use what you have. But if you think tech rescue is going to be a big part of your operations, or you're purchasing specifically for that, some of the characteristics I think are common. You want it to be durable. You want kind of good warranties with it. I think on the tech rescue side, I think typically used to moving lighter than you are on the structural side. You're purposely putting on 50 pounds of gear. So I think on the tech rescue side, maybe the size and weight come into play a little bit more. A higher resolution is important, particularly if you're looking at a fire is usually big, large things, big, huge heat things that we're looking for. We're only detect subtle differences. The resolution can matter. For hazmat, maybe the zoom to be able to not get so close. And maybe more for hazmat, because hazmat can have a cost recovery element to it. Having a DVR for documentation purposes might help. If you bill carriers for the hazmat, then having the ability to document what you encountered could be helpful too.
There are probably those watching this who are like, yeah, thanks, but we're already integrating this into our tech rescue operations. For those departments that, for those in the audience who might be like, I hadn't thought of that. How, but I have no idea how to even introduce this into our tech rescue operations. What advice would you have for them? How can they introduce it, and how can they help influence using thermal imaging in their tech rescue operation?
Yeah. So I will, and it may sound like a broken record at some point, but I just can't encourage people enough to not be afraid to just play with them. I mean, you could use a more technical term if you want to, but it's through experimentation that you will find the opportunities for it to be valuable. If all we do is we employ it when we think it might be valuable, then there's no opportunity at discovery there. And so if you're, if you're training, say, a rope situation, and maybe you're doing multiple evolutions, so you're on deck while another team is doing that evolution, that's an opportunity to get the imager out and start looking at and investigating what you're seeing. Like I said, in the simplest form, it's just anomaly detection. You're looking for the thing that is out of place. Once you find it, then investigate it. Go find out where that extra heat came from, type stuff. So experiment and play, I think, is a huge part of it. There's also just the behavioral aspect of making sure it's out of its charger during training. Again, if it doesn't do any good to think about going to get it, you actually just have to take it off and bring it along with, even when you don't know what its value would be. Because the opportunity here is not that the thermal imager is going to make your tech rescue skills better. It's not going to do that. It's not going to tie any knots in the rope, and it's not going to tell you exactly what mechanical advantage you need. What it's offering is the opportunity to have more information about what you're doing. And that information leads to more informed decisions, strategies, tactics. You know, can you operate without it? Of course. Fire service has done that for hundreds of years. Adaptive, creative group. But could you operate better with it? Maybe. And you need to experiment and find those opportunities.
Okay, well, before I let you go, I'm a big fan of takeaways with these types of things. And so, are there any takeaways you definitely like for the audience where if you don't walk away with anything else, this is what I want you to walk away with? Anything?
Sure. So, number one, nothing's going to happen with it in its charger. Right. It has to just come out of the charger. And this doesn't even pertain necessarily to tech rescue. It's just all the time. If you're out doing fire inspections, take the imager and get used to what buildings look like when they're not on fire. That becomes really helpful information when they are, because you know what normal looks like. It'll be easier to spot abnormal. So, don't leave it sitting in its charger. Take it and use it. And then second, all the things that we've suggested here, operations or after the call is not the place to experiment with it. It's before that. It's so that you can get those patterns built up in your head. You can understand the information that's coming in. So, I think if you were a tech rescue team leader or you're in charge of training, trying to conduct a classroom session on thermal imaging in tech rescue can be hard. But if you're already doing tech rescue, simply incorporate the thermal imager to that training you're trying to do. If you're teaching, high angle, it's fine to incorporate. If you're teaching auto extrication, so rather than treating it as a set aside technology, just treat it as another tool that could apply to the training I'm already trying to accomplish in the same way that you would use a flashlight if it's at night.
All right, perfect. Well, again, Brad, my thanks to you again for joining me. You have been watching the most recent episode of TIC Talk. We covered technical rescue in this one. If you are interested in previous episodes of TIC Talk, please visit fireapparatusmagazine.com/podcast. So again, my thanks to you, Brad, for sitting down with me today. We will have more episodes of TIC Talk coming. So keep watching fireapparatus.com. And Brad, have a good one. Stay safe out there, everybody. And we'll see you at the next one.
Thanks, Chris.